In this tutorial, I'll be teaching you guys how to make the tool paths for this designated figure over here. And in the next upcoming videos, I'll be making a two-part videos about how to make the wireframe for this shape over here. It's really long, it's a big structure, and it's really complex how to make this specific shape over here. Especially into making this ellipse shapes over here, and how to make this over here also looking like an ellipse. Now, we jump straight to our tool paths. We go to our stock setup. Our tool settings will be, we're going to have a default number program is as 2. This is our second tutorial. Feed calculation from materials, as we always will choose. Tool path configuration will be assigned tool number sequentially. Always keep it at that. And advanced options will be, make sure to check all of these because we need them all. Override defaults with motor values, clearance height, retract height, and feed plane. We need all of that. And material, easy. We're going to go to select mill current. We're going to go here to the source, mill library. We're going to see here as are all these material, but as a basic material, we go to aluminum 6061. Now, we jump to our stock setup. Last tutorial, I taught you guys a shape that was rectangular. This tutorial, it is more of a cylindrical. Make sure the axis is at Z. Display, all this should be a default, and then our Z and Y should be at 10. It could be counted as X also in this one. 10 and 2. You can copy this exact numbers to recreate this exact figure as shown right here. Stock origin and view coordinates. Make sure X and Y is 0 and Z as -2. Jumping right in. Make sure everything here is all solids, all surfaces. And then we jump straight here. Our first tool path will be a 2D high-speed area mill. We're going to go to parameters. We're going to see our machining region. As you can see, the machining region is the outside over here. And make sure to have an avoidance region, which is this part over here. We don't want to affect any of this because we need it to make our ellipse and our profile, as you can see here. Okay, we go to our tool right away. We're going to see we needed a 3/4 flat end mill. I'll teach you guys how to make that to get that 3/4 flat end mill over here. We're going to select tool library. We're going to go to filter. You guys are going to have this as all. Make sure it's none. We're going to go flat end mill. We're going to go to equal. As you can see, go to equal and put here 3/4. Convert it to this one. Boom. 3/4 flat end mill. And you can get that right here. Make sure to comment. As I told you in the last video, make sure to put a comment to tell the machinists what toolpath is, what this toolpath will be doing right now. So this first thing we'll be doing, machine the elliptical shape as a boss. I'll teach you guys what a boss is in the next video. We go to our cut parameters, cutting method climb. Everything here should be default. Make sure the stock on the walls and floors is at 0. We want to take this precise cut as we don't need to leave any excess. Depth of cuts max, rough step is 1/4, 0.25, and the rest should be all default. We're going to need transition in this part, and then we're going to put as entry helix. Radius is 0.25. Plunge, make sure the entry feed is at plunge rate, and all this should be again as default. Linking parameter, clearance, we need 0. It should be at absolute. Retract 0.25, absolute. Feed plane 0.1 as incremental. Top of stock, we don't need any stock, absolute. And depth is going to be -0.75. Make sure coolant is on for safe demachining. Now, jumping into our second tool path, as we can see, it's a 2D high-speed dynamic mill. Machining region should be, again, the same location, just to clean everything up. Avoidance region, make sure this part, again, this time is the outside. We don't want to take away the outside. Now we go straight to our tool. It's going to be the same thing, 3/4 flat end mill. And our comment will be dynamic mill the step, whatever's left over from the last cut. Go to cut parameters. Cutting method is going to be climb. Everything here should be default, and the stock on the walls and floor should be 0. We don't need any extra stock. Entry motion should be helix only. Helix radius should be 0.25. Everything here should be at default. Linking parameter, clearance is 2.0. Absolute, retract 0.25, absolute, feed plane 0.1, incremental. Top of stock, we need a top of stock in this one. -0.75 as absolute, and depth is -1.5 as absolute. Coolant on, and then we go to our third toolpath will be a pocket. Now, chain geometry will be this one over here. As you can see, I'm going to put you in a top, and you can see what we're doing here in Pocket is to make these letters in this profile over here. And in order for that, we need a lot of chains. And then you can see as the chains, we're gonna choose the M here, we're gonna choose the bottom of the A, the top of the A, the S over here, T, and all this stuff. As you can see right here, we're gonna press OK. Our tool will be a 1/8 flat end mill. Make sure the comment will be pocket the inside of the ellipse, leaving the letters as islands. So we're going to be just keep pocketing and leaving the letters as an island in the middle of the shape. Okay, so our cutting parameters will be, of course, climb, pocket type standard, and then this should be all default, but the stock to leave on walls and floors is at 0. Roughing, make sure to have roughing, and make sure it says over here constant overlap spiral. We're trying to do it in an overlapping spiral on each of these letters. Everything here should be default. The only thing you should be selecting is this one over here. Entry motion, everything here should be default. I think only the minimum radius is 50. And then 0.625 over here. Max radius is 100 and 0.25. Everything is as shown. We're going to go to finishing, spacing as 10 thou. And now we go to lead in and out. Make sure the length is at 60 and 75 thou over here. And then our radius will be 60 and 75 thou again. Make sure to press this so that the entry and exit will be the same exact. Same. Depth of cuts, make sure it's 50 thou over here. Breakthrough, we don't need any breakthrough. Linking parameters, make sure the clearance is 2.0 as absolute. Recheck 0.25 absolute. Feed plane 0.1 incremental. Top of stock, we don't need any top of stock. 0 at absolute. Depth is negative 0.125 at absolute. Coolant is on. We're gonna press OK, and this should be our final result. As you can see from the simulation, we're gonna be seeing the 3/4 end mill cutting this outside diameter all the way around, clearing all this part over here. And then we're gonna see this over here, this little ellipse just shown over here. This is gonna be all cut, of course. We don't need this excess. Most important, this should be the same. And now he's gonna be making the inside letters over here. Thank you guys for watching, and I'll see you in the next video.